Hi there, welcome back. We have some progress. Quite a bit of it actually. Where I last left off, this desk was a total mess. And now it's still a bit of a mess, but actually there's some order. And let me show you what I've done. So what are we looking at here? Or rather, what are we looking at that's different? Well, that is different. That selenium rectifier has now got one of those bridge rectifiers placed underneath it. The plates and everything else you're seeing are purely cosmetic. I dismantled the other one and sort of rebuilt it with insulating pads between the layers and connected the bridge rectifier underneath. I wanted the cosmetic effect to be exactly the same as it was before. So we've got a new rectifier over there. And we don't have the problem of too much voltage drop or excessive heat or anything like that. The other thing is the resistor. Coming out of the new rectifier that we have on the underside, this is the B+ rectifier. It comes out, it goes in through that resistor, which is a 47 ohm, 25 watt, comes out of there and it goes into the capacitor. That had to be done that way. I had to screw it on with thermal paste to the chassis itself, because this will get slightly warm, if not hot. And this is the best way, and it's the best place to put it in. So unfortunately, we are deviating a bit from the original look, but it's unavoidable, and it makes this whole thing a lot safer. So we've got the two main changes that I wanted doing done. And now what we want to see is what voltages we get. Will we have solved the problem? Let us find out. So what do we have here? We have little brother is measuring the bias voltage, the negative bias voltage to the output tubes. So it's measuring it there at that 33 ohm resistor. And big brother is measuring B+. Start off with full limit, maximum limit, and on, and we'll hit the switch in the front here, and the light flicked on the back there, and then it's going haywire now because it's starting to draw some current. So we've got -9 point something, -10. We've got very little voltage on there because something's wrong. It's AC. Damn it. I'm still learning to use Big Brother. 246. Let's let that stabilize, and then I'll start giving it more juice, reducing the limit on the dim bulb tester. The tubes are starting to conduct. I've got no signal going in, obviously. So, what do we have here? 160 something. Let me give it a bit more current. We've now got 200 milliamps flowing through from the mains. We're going to give it a bit more current. We've got 260 flowing through from the mains. And give it the last light bulb. We've got 300 milliamps flowing in. 300 milliamps, and it's seeing 202 volts, 200 volts. So it looks like it's safe to take away the limit completely, and that's exactly what I'm going to do right now. Okay, so we are seeing 230 volts coming in. We are seeing 390 milliamps. And we are seeing 270 volts, 269. It's still coming down. So this thing is coming in line with the 265 that we expected to see. Now I've got -14, I've got nearly -15 volts bias, because I've still got that extra 220 ohm resistor that's affecting the negative bias. I want this nice and big negative so that the current flowing through the tubes is controlled. If I remove it, I'm keeping an eye on the dim bulb tester, which is showing 400 milliamps, 410 milliamps. And just so you know, the datasheet says it should draw 100 VA. Now, This thing has got 230 volts, it's got 400 milliamps, that comes out, or 410 milliamps, that comes out at 97 or so, just under 100 VA. So it's fine, okay? So if I remove that extra resistor, which I do very simply by doing that, now I've got minus 13 volts, I've got 260 supply, and I've got 450 milliamps coming through. It's gone up a bit, it's gone just over 100 VA. But I think we're actually fine. Although I'm not going to bet on that. I'm still going to put this thing back. Actually, it's under control. Let me look at the other voltages here. So we've got 260 B plus, B2 plus is, we've got two B2 pluses, right? We've got the one on the right hand side without the preamp. That's there. So 200 and let's call it 204. On the data sheet it says without the preamp 210. So we're good, 204. On this side we've actually got 170, which isn't bad either. It could just be slightly irregular or slightly imbalanced tubes, not drawing as much current as it should, but our voltages are there. So what is it in summary? It's 260, 204, 204, 205, and over there 170. No, that 170 is not the one going to the, that's not the voltage going to the, that's the one. That's going to the preamp, 151, 152, which is good. It's supposed to be 160. Now, I still think we've got slightly high current on there, because if I do this, and that is if I put that resistor back on, that voltage goes to minus 15. And now if we measure these voltages, we've got B plus 267, 268. That one there, the side without the preamp, 210, which is what it's supposed to be. The side with the preamp is seeing 176, it's supposed to be 180. And the preamp itself is seeing 156, it's supposed to be 160. Brilliant. Okay, I'm not sure if I should just leave it like this. I'm actually going to measure the current again by taking out the fuse and measuring the current, seeing what we've got. I might have to settle for a different resistor value, just somewhere between what it's seeing at the moment. At the moment I've got 220 in parallel, 220, that's 110 ohms. I might, have to go to 150 ohms or 180 ohms. So that's what I'm going to set up. I'm going to set it up to measure the current, the total B plus current. Be right back. Okay, we're now set up with the big brother is across the fuse, which I've removed. That's measuring the total B plus current. Bear in mind that the following on circuits from the tubes, from the power tubes themselves, draw about 3-4 milliamps, not much more than that. So whatever current I get on there, if I remove 4 milliamps or 3 milliamps, divide by 2, that should be the current, the average current going through the power tubes. That there is the bias voltage. So let me give it again. I'm going to leave minimum limit on, but I'm going to put limit. Not that crazy. Very little current going through there. At the moment, the tubes are warming up. And there it starts. That's amp, so 0.12, got 120, 29, 130. Now I'm going to remove the limit, bypass the limiter. See what we get, 180, 182. 190. Bloody hell, that's exactly what I wanted. That gives me just under 100 milliamps per tube. So it's gone up to 0.2 amps. 0.2 amps. And the little change we're getting on there is practically the current going through the extra circuits. So 203 milliamps, it'll probably go a little bit higher. So we've got 100 milliamps per tube. That's bloody hell close to textbook. So I think I'm going to leave it like this. I'm actually going to leave that resistor in place right there. It's perfect. Okay. One thing I want to see is how hot this guy gets. It's at 39 degrees C. Just under 40 degrees C. That's pretty good. That's good. I can touch it. But there's B plus on the end, so yeah, it's just warm. That is perfect. That is bloody perfect. Okay, that's exactly where I'm leaving it. And in answer to a question that one of the viewers posed on the comments, that resistor is there, not before the transformer, not after the transformer. It's actually after the rectifier, because the 230 coming in here, that's the voltage coming in, 230. I can see it there on the dim bulb tester. The 230 coming in is actually providing a heater voltage of 6.2 volts. It's supposed to be 6.3. So if anything, that could go a bit higher. The selection I have at the back is for 230 to 250. So the voltage coming in and the secondary voltage being produced is exactly right. The problem was that when it was going through the old rectifier underneath there was a huge voltage drop across the rectifier, which was bringing that voltage, the B plus, way down. So I wanted to bring just the B plus down and then work forward from that. That's why this resistor is in line with the B plus. And it does get quite warm. I mean, we're getting about 15 volts drop over there, 15 volts drop, 200 milliamps, which is the current going through there. So what's that, 3 watts? 3 watts? Doesn't seem like much, but you leave 3 watts roasting for a long time, and you can probably put your frankfurters on the top there, and it'll get hot. So it's always better to use one that has a good heat sink and actually bolt it to the chassis, because that's a good dissipator. This thing actually sits underneath, so when you flip this around, that's underneath. So you've got to get the heat to go somewhere. Anyway, this is pretty steady. Minus 14.9 and 206 milliamps. Why this 200? Why this minus 15 rather than minus 13.6? I don't know. If we leave it at minus, well, actually, let me show you what happens. Watch that current when I remove this resistor. So when I drop that voltage comes to 13. That thing starts going up a bit. It's not too much. It's not too much, 230, but it's still higher than it should be. Watch now. You put that on and it comes down. That is really biasing the tube to keep it within the constraints of its power dissipation, which I believe is 25 watts. I believe it's 25 watts. Now, I don't want to do the math, but you can actually look at the tube, the chart, and you can see where the safe line is. But sometimes it's best just to follow the textbook examples. And 100 milliamp per tube is actually sort of hot biased, but this is a Class A amplifier. This is not AB. If it was AB, I think you sort of keep it within about, what is it, about 70 milliamps, but then you'd have a higher B plus. It just goes all over the place. Anyway, this is what we got. And now what I'm going to do is I'm going to flick everything around and prepare it so we can actually see what the output looks like. Brilliant. I'm actually happy. And the little brothers behave well. Okay, we're in business. I have this set up for the audio test on screen. I have actually tested this. I've been playing music on this thing for a long time. and it sounds bloody amazing. So this is just to fill you in. I've set this up with a signal coming in, the same signal, 1 kilohertz sine wave, 100 millivolts RMS coming in to the left and right channel. I've got the balance straight in the middle, treble, middle, bass, middle, selector on tape, volume on 5. I have already inserted that 220 ohm resistor in there, so we've got 110 ohms. I soldered the second resistor in parallel with that 220, so we've got effective 110 there, and that seems to do the trick. I've found that the sound is not affected by that, by the bias. It sounds brilliant. It's running a safe bias current, which is exactly what we want. So let me show you what comes up on the scope. So this is what we've got. We've got a slight imbalance between the one channel and the other. I can't honestly tell you if it's left or right, but the yellow trace is at 2 volts RMS, 1.99. The blue trace is 1.74. In terms of audible loudness, that's not that much, but it does show an imbalance. And I'm actually wondering if I'm almost certain that this has to do with that different supply voltage that this driver, the pre-driver on the one channel, has different to the other one. But what we're going to do here, let me just show you. They track quite well. It gets a little bit more extreme when we get to higher voltages. We put this on 2 volts per division. So that is, actually, let me make it 5 volts per division. Let's get adventurous. I've actually got a dummy load on here, obviously. It's a 100 watt 8 ohm resistor on each side, so that shouldn't be a problem. The supply draw from the mains is a constant 400 milliamps at 231 volts, which is bloody perfect. It's exactly what the manual says. Now if I up this, it starts clipping. The yellow channel is clipping uniformly, top and bottom, at 8 volts. The other one goes a bit further and clips at 8 volts as well. So 8 times 8, 64 divided by 8, we've got 8 clean watts coming out of this thing. Not 9 as they claim, but it's 8. Close enough. And believe me, when I put this thing on the speakers, I couldn't go beyond 4. So it's pretty loud enough. Now, what is the solution to that imbalance? Well, I'm not going to do anything about it because that's the way it's designed. If I had to do something about it, in other words, if I wanted to really get a perfect balance when I'm playing music, this is what I would do. I would go to the balance control. So just by moving that from center to about L1, I'm watching the screen there, that's perfectly balanced between L1 and L2. So that's what you need to do to compensate if you go the other way. Actually, this is damn near clipping. Let me get the volume down. Let's do that instead. 2 volts per division, we're seeing about 2.4 volts on the left there. So if actually that looks better. If I want to balance them, I go to L1, left 1, and it's perfectly balanced. And it stays pretty much perfectly balanced at different volume levels, as you can see. So I've got, actually there I've got 2 volts RMS, that's a half a watt. That's pretty low power, and I'm feeding in a 100 millivolts RMS signal. And it is giving me, I've got the volume control on 5. So guys, this is it. This thing is bloody brilliant. It works very well. I've cleaned the pots, I've cleaned the switches. I know this is done. All we need to do is put some royalty-free music on here and play some music, although obviously you won't hear much. You won't really hear what's going on. I'm going to connect this to, let me show you these speakers. What I have here is a pair of full range speakers that I built myself using the Mark Audio drivers, full range drivers. These things turned out very, very well. I built this in solid wood. I've got to tell you, the woodwork here cost me about 5 times more than the drivers. These things sound very good actually for homemade full range speakers. And that's what I've been playing this on, and that's what I'm going to be playing this on again. Just so you get an idea of, well, this is going to be picking it up on the lapel microphone, and then through all the post editing and everything else. So I don't expect you'll get the experience that I'm getting when I listen to it. There's one other person who's going to, and that's the owner. He's been following the series, so I think he'll be pretty pleased that this thing is finally done. All right, I've got something on the iPad. It's going into the tape. Volume low. That's just to give you a feel of it. Let's try something else. That music's bloody horrible. And there we have it. This thing sounds bloody amazing. Forgive the choice of music. Royalty-free isn't exactly the one with the best choices, but you know how it is. Well, project is done, and I'm pleased. I'm happy to say that I've really enjoyed this. I think I've achieved what I set out to achieve. Probably surpassed it to a degree, especially with some of the stuffing of the secondary capacitors, which I'd never done before, and found that it wasn't really that difficult. Couldn't do it to all of them, but you can try. So here we go. This one's going back, and my friend is going to be very pleased, I'm sure. And I hope that you've enjoyed the series. I hope that, like me, you've learned something. And if you have enjoyed it, please subscribe, share, like, click the bell icon, you know, all that jazz. And if you want to support the channel, by all means do so on Patreon. Thanks very much, and I'll see you again soon. Bye for now.